If there are exact differentials, there must be inexact differentials. So what is an inexact differential? Inexact differentials are associated with path functions. Since heat and work are both associated with the process of transferring energy, they are path functions or process functions. If I want to designate a small incremental amount of energy transferred as heat or a small incremental amount of energy transferred as work, I'm going to designate this using a different symbol. The D with a slash through it indicates that I have an inexact differential. I have to treat these differently because their integrals are path integrals. So I cannot integrate dq or dw directly. I have to equate those to a state function and then integrate. In addition, the result of integrating a path function is simply the value of that function and not delta q, because I cannot equate a certain amount of heat to a state of the system. There is no such thing as initial amount of heat or a final amount of heat. So how do I integrate dW or dQ? Let's look at an example. If I want to determine the amount of pressure volume work done in a system, I know that dW is equal to minus P dV. So if I want to integrate this, I can see that I have equated dW to state functions, pressure and volume. And so I can integrate pressure times volume, but I must know how the pressure depends on the volume. So I need to know the path that I have taken and how that pressure changes as a function of volume. If I do this reversibly, then, and I have an ideal gas in my system, then I know that the pressure is equal to nRT over V. And so I can make that substitution for the pressure, and now I have an integral that I can do. As long as I'm at constant temperature, I can pull n, r, and t out of the integral and integrate dV over V to get natural log of V final over V initial. So by equating the inexact differential to an exact differential, a state function, I can do the integral and I can determine the amount of work done in that process.